Hi everyone, Manisha here, and today we will be starting the chapter Electricity. At the end of this video, you will have a basic knowledge about electric charge. You must have heard of the terms lightning, flashlight, batteries, computers, bulb, the shock you feel when you shuffle across the carpet and then touch something. There's a common link between them. It is electricity. Now, electricity is study of charges. Now, charge is the property of matter due to which it produces and experiences electrical and magnetic effects. Charge are of two types, positive charge and negative charge. Positive charge means deficiency of electrons. Negative charge means accumulation of electrons or higher concentration of electrons. Its unit is Coulomb, denoted as uppercase letter C. Now, since we are talking about study of charges, charges can be at rest or in motion. The study of charges at rest is known as static electricity. Let me explain with an example. When we rub a silk cloth on a glass rod, some electrons from this glass rod get transferred to the silk cloth of same magnitude. Hence, the rod attains an overall positive charge and the silk cloth attains an overall negative charge. Hence, the attraction between them, because like charges repel and unlike charges attract each other. Another example, on rubbing the plastic comb on hair, the comb attracts paper pieces. Why? Because the comb attains a charge on rubbing on the hair. Let that charge be positive charge. When we bring the comb closer to the paper pieces, the negative charges will accumulate on the surface and hence there will be an attraction between the comb and the paper pieces. Another example is lightning. Why lightning occurs? Because lightning is created when air, water droplets, and even ice crystals rub violently against each other inside a thundercloud. They gather positive or negative electrical charges so that soon one cloud becomes positively charged and another cloud becomes negatively charged. And the force of attraction between them becomes so strong that they push through the air towards each other and we have the lightning. Now, current electricity. The study of charges in motion is known as current electricity. Now, let me explain this phenomenon within circuit. In this circuit, the battery is connected across the bulb through wires. This battery has two terminals, positive terminal and a negative terminal. The wires are actually conductors in which the electrons can flow easily. And there is a bulb. When we are connecting the battery across the bulb, it is creating an imbalance of charges, due to which the electrons from the higher concentration is flowing through the bulb to the lower concentration. Hence, the bulb is glowing. This is the phenomenon of current electricity. Now, you must know that electrons flow from positive to negative, whereas the current flows from negative to positive. It has many examples in day-to-day life: heating, refrigeration, air conditioning, etc. Now, to understand this concept much better, let's go back to the basic we have read, atoms. Now, atoms are the fundamental building blocks of matter. Each atom consists of three particles named protons, which has positive charge, electrons, which has negative charge, and neutrons, which have no charge. Now, each atom has equal number of protons and electrons, meaning the net charge of atom is zero. In solid materials, protons are fixed, but some electrons are free to move around. These electrons are known as free electrons. Now, free electrons can be defined as the electrons present in the outer shell of an atom as valence electrons and which can be easily displaced when an external force is applied on it. These electrons are known as free electrons. How freely the electrons move depends upon the material we are using. The material can be described as two types, conductors and insulators. Conductors, like metals in which the electrons can move freely, where insulators, like wood, there are no free electrons, thus limiting their flow. You can see this from this video, where in the circuit we are using the insulator named ceramic and a metal. The insulator is blocking the flow of currents, due to which the bulb is not glowing, whereas the metal, which allows the free flow of electrons, due to which the current flows and the bulb glows. Now, what causes these electrons to move? Imbalance of charges. Imbalance of charge means when there is higher concentration of electrons on one side and lower concentration of electron on the other side, and the path is closed, then this imbalance of charges causes the electrons to move from higher concentration to lower concentration to attain equilibrium. For example, when a silk rod is rubbed against the glass rod, silk rod stores the electrons, thus giving the rod an overall positive charge. Hence, they get an excited state. To attain equilibrium, there is an attraction between them. Now, these interactions between charges can be calculated in terms of force in newtons. Before we calculate force, we need to measure the value of charges. Now, since objects can have both positive and negative charge, hence Q can have both positive and negative values. For example, charge on one electron is 1.6 into 10 to the power minus 19 coulomb. Hence, 1 coulomb of charge contains 1 by 1.6 into 10 to the power minus 19, which is equal to 6.25 times 10 to the power 18 number of electrons. Now that we know how to measure the charge, we can calculate the force between particles. Here, we are using coulombs to find newtons, whereas in gravitational law, we were using kilograms to find newtons. Now, the formula to find the force is Ke multiplied by Q1 Q2 divided by R square. Now, this is known as Coulombs Law. Coulombs Law states that electric force of attraction between two charged particles at rest is directly proportional to the product of two charges Q and Q2 and inversely proportional to the square of distance between them, that is R square. Now, since the charges can have either positive or negative values, hence the force can also have both positive or negative values. Hence, they can be attractive or repulsive depending on the sign of the charges. Now, this Ke represents Coulomb's constant or proportionality constant, and its value is 9 times 10 to the power 9 Newton meter square per Coulomb square. A quantization of electric charge. Electric charge on a body is always an integral multiple of charge on an electron. This is known as quantization of charge. Its formula is Q is equal to N. Q is the total charge or overall charge on an object. N is the number of electrons or protons which are transferred from one body to another. And E is charge of one electron or proton. So E can have both positive or negative value depending on whether it is an electron or a proton. Now, next is conservation of charge. The law of conservation of charge states that electric charge can neither be created nor be destroyed. It means that the charge of an isolated system will always remain constant. This means that any system that is not exchanging mass or energy with its surrounding will never have a different total charge at any two times. For example, if two objects in an isolated system have a net charge of 0 and one object exchanges 1 million electrons to the other, the object with excess electrons will be negatively charged and the object with reduced number of electrons will have a positive charge of the same magnitude. The total charge of the system has not and will never change. This concept is very important to understand. Hope you understood the concept of electric charge, and in case of any doubts, feel free to use the comment section. See you next time.